Okay, just a quick video on this question. So I've made a rough sketch of question 12. This is from Equations of Line 1 worksheet, which I posted yesterday and the day before. First thing we've got to do is find the equation of the diagonals, and we've got to find the point of intersection of the diagonals as well. We've got a diagram, which is ideal, so we can see where everything is. Okay, starting off with PR. So again, we need a point, we need the gradient, and then that allows us to write down the equation. Quite straightforward for PR. Gradient, we've got 2 points in the line, so it's just y2 minus y1. Just careful with that, you're taking away a negative. And then x2, take away x1. So we get 16 over 8, which simplifies down to 2. So we know the gradient's 2. Now, like I said, keep saying, look at the diagram. Does it make sense that PR has a positive gradient? Yes, it does, because it slopes upwards from left to right. So we should have a positive gradient. Oops, I've done that in the point, but that's fine. So we can just move that across there. Point, we're kind of two choices. I'm just going to go with 10, 15. Sorry, I'll put that in there. And that obviously should have been done over there. Okay, so it's just y minus b equals m times x minus a now. Y minus 15 equals 2 times x minus 10. So we get y minus 2x equals 2 times negative 10 is negative 20. Negative 20 add 15 is negative 5. Before I go any further, I'm going to check that that's correct. I used that point there to get the equation. So let's check that that's correct using this point here. People are getting themselves into bother by not checking and moving on to the next step. So y, negative 1, take away 2 times 2 should equal negative 5, and it does. Negative 1, take away 4 is negative 5. So I've used that point in that equation. The equation is true, so I now know that that's correct. Okay, second diagonal, which is SQ. Again, if I look at SQ, I'm looking for a negative gradient. Should get a negative gradient. Now, I don't have 2 points on that line. I don't have any easy way just now of finding out what the point S is, but I do know that when we're dealing with kites and lombi, that they actually intersect, the diagonals intersect the right angles, so I'm going to use m1 times m2 equals negative 1 to get the gradient. Okay, just slide this up a wee bit. So the point, easy for that one, we've got Q, which is 7, 4. Gradient, and the equation. Okay, so I'm going to get m using the fact that m1 times m2 equals negative 1. Now, the gradient of PR times the gradient of QS or SQ must equal negative 1 because they're intersecting at right angles, as you can see from the diagram. Okay, so that means that the gradient of SQ is simply going to be minus a half. Okay, so we've got the gradient, we've got the point, y minus b equals m times x minus a. So y minus 4 equals negative a half times x minus 7. Again, we've got the fraction, let's multiply through by 2 to get rid of the denominator of the fraction. And again, just making sure that everything on the left hand side is multiplied by 2. Careful, that leaves us with negative 1. So let's multiply on that second bracket by negative 1. Collecting like terms. Okay, and we've got 15 there. Okay, it's not an ideal check, but a rough check just now is using 7, 4 and subbing that into the equation and making sure the equation comes true. So 2 times 4 is 8, 8 add on 7 is 15. Unfortunately, I don't have a different point to check that one. Okay, points of intersection, it's just going to be simultaneous equations. So we've got 2y plus x equals 15. And the other one we've got is y minus 2x equals negative 5. Okay, equation 1, equation 2. It would make sense to work with the x's. I've already got the difference, got a plus minus, and that's what we want. So all I'm going to do is I'm going to take equation 1 and I'm just going to multiply it by 2. So that gets me 4y plus 2x equals 30. dropping down the second equation, down there, equals -5. We're going to add to eliminate the x's. It's going to get me 5y equals 25. So that means that y is 5. Okay then, so when y equals 5, let's put it into the first equation, doesn't really matter. 2 times 5, add on x, it's going to equal 15, and solving that for x is going to get us that x is 5. Okay, so t is going to be the 0.55. Right, again I'm going to check this and I'm going to make sure that that's correct. So let's check that in equation 2. So 5 take away 2 times 5 must equal -5. 5 take away 10 is -5. So note that's correct. Okay, so the last bit of this then is finding out what S is. That's actually just part B. So again, back to the diagram. Put this in that this is 5, 5. Okay, so it's a stepping out question. I've done a video on this before. Basically how we get from Q to T is the exact same as how we get from T to S. So if I can work out how to get from Q to T, I can do the same and that will get me from T to S. And it's just a case of looking at the differences in the X coordinates and the Y coordinates. To go from 7 to 5, I take away 2. So what I'm going to do is I'm going to take away another 2 and that's going to get me the X coordinate of S. If I look at the difference between the Y coordinates, how do I get from 4 to 5? Well, I add 1. So again, taking the step up to T, I'm just going to add 1 and I'm going to get 6. So S would be 3, 6.